Hello, I'm Matt Reardon, and thanks for watching this Wednesday evening, October 11th West Weather Update brought to you by Nutrien Ag Solutions. To start here, we're just looking at the last 3 days of precipitation. We had the system come through early in the week, drop some rainfall on the Pacific Northwest, even got into parts of California here. It's brought temperatures down really across the board, at least in the northern and western kind of half of the region here. We can see the Willamette Valley got into about an inch of rainfall, a little bit further if you go toward the eastern sections of the valley here. Even got some rain into eastern Washington, lesser amounts in the Snake River Valley and Treasure Valley area, but the Palouse here in southeastern Washington, far northwest Idaho, getting upwards of a half inch, maybe even a little bit more in some of these locations. Jumping over to the Golden Triangle, they're still seeing some of these kind of spotty showers move through there. They've seen some spotty amounts. You can see anywhere from trace, kind of outlining the highways on the triangle there, but spotty amounts in between, pushing up toward a quarter inch, maybe a little bit more. So another healthy system. We've seen kind of an active period of just system after system coming through. I think that's waning a bit. We'll get into the forecast. We'll discuss that a bit. I think this kind of progressive pattern where we're swinging up and down, watching the next Pacific Northwest system come in and drop, an inch or two of rainfall in the Willamette Valley is slowly coming to an end here as we kind of get through October. We'll talk about that in just a bit here. I did want to quickly go through the 7-day forecast. I'm doing this video a little bit backwards, so I want to take a deeper dive into El Nino. It feels like I've had a lot of questions over the kind of forecast, where we are in El Nino. We talked about it quite a bit in summer. So I want to do the forecast first and just give us time to kind of break down what we're seeing with El Nino right here, beginning of October, what I'm seeing going into winter as far as the rainfall forecast for California and the western region as a whole, to see what kind of El Nino we'll get into. But first we have to get through the 7-day forecast. So this is just looking at the precipitation from the ECMWF model. We'll take this over the next 7 days. We can see here, if I make this valid Wednesday evening, some of the rainfall still pushing through parts of the Pacific Northwest. That really waning through the night tonight on Wednesday evening. Could see some lingering showers tomorrow morning in the Golden Triangle as the system wraps up in the Central Plains and really moves east of the divide out of our area of concern. So we go through Thursday and Friday, we clear things out a bit, warm up a bit, and then if you look toward the northwest, we see another system coming on shore, just a weak kind of clipper system impacting parts of the Pacific Northwest. Not expecting a big rain event here in the Willamette Valley, but some inclement weather moving through Washington, bringing temperatures down a bit across the northwest region just briefly here, really Saturday morning and Saturday through the day. Sunday, we can still see some remnant showers pushing through there. And then another more potent system now all the way out Monday p.m., really getting into Monday night here. This one looking a bit more bona fide as a rainmaker across the Willamette Valley, similar really kind of to the one we just saw almost a week before this one forecasted out here, October 17th. This one more kind of focused in that southwest to northeast trajectory, and that keeps it from really getting into other parts of the states here across the western region. Just a glancing blow perhaps to northwest Montana and northern Idaho, before that shoots off into the northern plains and the middle part of the country. We're all the way out to October 19th now. This is we've turned into a 8-day forecast here, but we're looking at a potential prolonged warming up of the temperatures over the next kind of 7 days plus, maybe even out further into October. And we're thinking the temperature or the precipitation, situation is going to dry out a bit there as well. And we might take a break from this kind of progressive system after system impacting the Pacific Northwest, which after 2 to 3 weeks of it maybe is a welcome change here. I want to jump over and look at temperatures. This is from the National Digital Forecast database, really the National Weather Service's forecast here for temperatures. The color here is by anomaly, so relative to average for what we'd expect here in early October, to give you a sense for the seasonality of the temperatures. And if we look at the high temperature anomalies today, you can see the very cold temperatures now having moved through with this cold front and the system as it's come through. If we take this out into Thursday, you'll see it tracking off toward the divide as the system gets out of the area. We finally start to warm up back towards seasonal temperatures and just a little bit above across the Pacific Northwest. Still fairly cool across the Central Valley and the coastal regions of California here on Friday. Start to warm up a little bit this weekend. We still have some systems coming through the Pacific Northwest and the Willamette Valley, but by and large, the region warming up as we get out into next week. There's that system we talked about Monday night, bringing temperatures down just a bit across the Northwest region, but quickly warming up again. There's that kind of broad trend. If you saw that over the 7-day forecast, we're starting to warm up and I think dry out a bit in the long-term forecast here. If we kind of look at what's going on up above, I'm not going to want to do that to see where we're going long-term. We still see this deep trough here across the Northeast Pacific here. That's helping to funnel these kind of successive frequent systems here into the Pacific Northwest. This is a rolling 5-day window. So as I take this out from October 13th through the 18th and I move that window out into next week, you'll see that trough weakening now in the northeastern Pacific, actually kind of retrograding west. And now we see an upper level ridge here, or this kind of mountain or upside down U shape in the jet stream, and that tends to bring heat in, tends to dry things out a bit. And this is now looking from Tuesday to Sunday all the way out now to October 22nd, that kind of 5-day rolling window. And this is really the impetus for that drier, warmer forecast now as we get toward that 3rd. And maybe even if you look at this forecast all the way out, again, getting way out there, day 10 to 15, leaning toward all the way out toward potentially the end of October, at least that last week, seeing a warmer and drier trend really wholesale across the western region, not seeing this kind of rapid successive system, low pressure system after low pressure system, 1.5 inches of rainfall in Salem, Oregon, seeing kind of a break from that there. Strong agreement from the Climate Prediction Center and the National Weather Service here, the long-range forecasters there. If you look at the 6 to 10-day forecast, dry across the western U.S. and very warm. Very high likelihood of above average temperatures there across California, Oregon, Washington. If I keep going, I'll name every state here across the western region. If I take that to the 8 to 14-day window here, October 19th to the 25th, pretty much the same story. So not a big change now, getting out into that week 2 and beyond forecast, not seeing these rolling progressive systems. And even if we look to the week 3 to 4, I don't typically look at this too closely because it's kind of getting out of our range of forecast confidence. But if we're leaning anyway through the end of October, warm west, dry west, cooler east, wetter east. So that forecast even staying consistent out to a 3 to 4 week forecast here. So getting a bit stagnant or blocked up here in the flow potentially to end the month of October. So that was my quick attempt to get through the forecast here so I can take a deeper dive into El Nino, try to give you a more seasonal forecast here. I'll start here. Whenever I say the word El Nino, certainly last year we were talking about La Nina. We're really starting and we're looking here in the central Pacific. So this area right here in the central Pacific, if these water temperatures, the sea surface temperatures are warmer than average, we're in an El Nino. And it's really that simple. If these waters warm up, they affect convective patterns across the equator. They affect tropical storms and hurricanes. We've been talking about that at the end of summer here and getting into early fall. And that tends to nudge, strengthen, shift the jet stream. And as you heard in the beginning of this video, that kind of positioning the strength of the jet stream, where those ridges sets up, where those troughs are in the Northeast Pacific, are going to establish the forecast going forward for the 7 days, let alone out into that kind of week 2 to week 3 forecast. So anything that affects that, El Nino, a huge driver of this global circulation in the equator, if that's going to affect the jet stream in winter and determine what kind of water you have, of course we're going to obsess over it. But it doesn't determine everything. No El Nino is the same. If it was, we could just textbook forecast every El Nino, that would make things pretty easy, and that's just not how it works. And our 2 most recent examples of El Nino, looking into the historical record, are great example of this. We had 2018 and 2019, which was really kind of a weak, maybe slightly moderate El Nino. And then, of course, we had the 2015 El Nino to 16, which was very strong, one of the strongest, if not the strongest, El Nino on record. And yet they were very different. And I kind of want to break those down more specifically here and hope those can teach us something or give us an idea of what to watch for as we go through our very own here 23-24 El Nino this year. So I'll start off, this is looking at our El Nino Index. This is essentially an average of those temperature differences across that box in the middle of the Pacific here for this year. And you can see the dates down here, July 19th through October 11th. And you can see we've very slowly strengthened this El Nino all the way from mid-July to now mid-October. We've kind of hardly stair-stepped our way just a few kind of tenths of a Celsius here to where we are in a moderately strong El Nino. So it's taken a while. This is not uncommon. El Nino is kind of more of a late season ramp up event. It's not uncommon in summer and fall for it to take its time to ramp up. Now, if I take you back to summer, some of the predictions for this year's El Nino were pretty extreme. The Bureau of Meteorology out of Australia remains the most extreme, with an El Nino peaking at a 2.87 degrees Celsius above average. That would be a very strong El Nino, but they were even stronger than that earlier this year. Some of these forecasts have been very aggressive. We've kind of walked those back a bit. We're still expecting a strong El Nino here, something around 2 degrees Celsius above average. Right now, we're just above 1. And if you think about it, it took us from July to October just to move above 1. We were at about 0.9, now we're about 1.1. But you can see a rapid strengthening all the way up to 2. So doubling from 1 to 2 in just a few months here, potentially peaking at some time in December and January at a very strong El Nino. Now, a question I get, okay, we're going to have a very strong El Nino. Does that mean we're going to have a very textbook El Nino? And unfortunately, the answer to that is I'm not sure, and I don't know if that kind of correlation holds true. I think it's more important that we're just in an El Nino versus a La Nina than whether we're at a 2.5 degrees Celsius anomalous El Nino versus maybe a 1.5. And again, going back to these 2 recent El Nino events, I think we can see that kind of correlation break down a bit, or the expectation of a very strong versus just a moderate El Nino. So I'm going to pick on Oxnard, California here, right? Kind of on the central coastline, a little bit toward the south, north of Los Angeles, but it kind of tells the story of really the state at large, whether we were in the Central Valley or the coastal part of California. This kind of graph here, this is this year's precipitation year to date. This middle curved black line, I've shown these before, is our average accrual of precipitation in Oxnard, California, so about 14 inches per year. This year, we went off the chart. We have to change the chart here clearly for Oxnard, California, and give it the benefit of the doubt, maybe push it up to 30 inches of rainfall or more to capture how much rainfall we've had this year, much of that falling early in the year with the January and March atmospheric river events. And I'm not necessarily showing it for this year. There are past years on this year-to-date chart. They're hard to see, but the 2018-2019 El Nino event is on here. 2018, at the end of the year, when we got into that weak to moderate El Nino, we started to see kind of the water year pick up here in November, December, not particularly strong. But then we shift over to 2019 as this green line hiding behind all the rainfall we had this year on this graph, and we can see the very strong precipitation events that we had, kind of equaling what we saw earlier this year in 2019. And again, what was not an El Nino to write home about. It wasn't a very strong El Nino, and yet for coastal California, parts of the Central Valley, the snow water content in the Sierra Nevadas, kind of wholesale, we delivered for California in terms of a bountiful water year, despite it not being a strong El Nino. Kind of, if we jump over to 2015 and 16, our very strong El Nino, which, I wouldn't blame you for thinking that was going to be a more textbook El Nino. And we look at the precipitation anomalies from that year, from December 1st all the way through March 31st, we almost had the opposite of a textbook El Nino. I mean, you've heard me say that the winter forecast, we're expecting wetter in central and southern California, Arizona, Nevada. Okay, well, we've reversed that. Now we, in 2015 and 16, had a wet Pacific Northwest, which our forecast right now is for potentially seasonal drought risk there going through wetter. We had a wet year up here in the Pacific Northwest, and the water year in parts of central southern California, Arizona, the Colorado River Basin was dry. So what I'm trying to see here, are there hints, are there lessons to be learned from these two recent examples? And if I jump over and look at snow water content, I think there's something of a story in here. So what I've plotted here are our maximum snow water content year in 1982, 1983, the last time before this year that we filled up the Tulare lake bed. I also plotted on here that 2015 and 16 snow water content water year here. We can see December through April, May, and June here on the bottom of this graphic. I've also plotted 2018 and 2019, that is in yellow. And this is just from the California Department of Water Resources here where I pulled this data from. If you actually go out to about January of both those years, so this is 2018, 2019, this yellow line of 2015, 2016, the green line, we actually were about the same all the way through the end of January, at least for snow water content across the state of California. It was from that date, really February 1st, that things diverged in each water year. And I've said it before where it's nice to get some of the water year, the rainfall, the snowfall in December and January, when there's not a lot of activity going on in terms of agriculture and work in the fields. But the bulk, the peak of the water year, the most kind of rapid rise, and when we get a lot of the water and snow is really in a short period between February and kind of mid-March. And you can actually see this in this light blue line is the average kind of accrual of snow water content before it melts as we get towards summer. And we rise pretty quickly from about 50%, which we take from November through February 1st just to get 50%. And then really from the beginning of February through the middle of March, we add that next 50% of snow water content. So the season, the water year can very often in some years be determined by what happens in February and March. And 18 and 19 was a great example of that, where it diverged from what we had in 15 and 16. We had a very bountiful water year kind of up toward this max in 82 and 83. And we ended up having a pretty good water year despite, again, a pretty weak or maybe even a moderate El Nino. And so naturally, you're going to want to see me go to sea surface temperatures. Let's figure out what happened in those years and give us a clue of what's going to happen this year. That's the goal. Here's our 2023 October 10th sea surface temperature anomalies. There's the El Nino strengthening in the Central Pacific. It tends to start in the Eastern Pacific. We see the warmer waters there. When we look to the north, we see all this anomalously warm water in the Pacific Ocean. We've noted that at times this year. Still a little bit of cool water here in the Northeast Pacific. This has warmed up recently here. This did cool down kind of in late September, but starting to warm up again. We still see the vestiges of this cold patch here east of Hawaii. We've talked about this and its influence on some hurricanes trying to sneak into the Central Pacific here. Keep note of these features because I'm going to refer back to them as we kind of go forward in the forecast here. But this graphic here, now we're jumping back to 2016, March 1st, trying to get an idea of where that kind of failure, if you will, in 2016 occurred when it diverged from 2018 and 2019. Now, if we look in the Central Pacific, it's kind of divided between the east side and the west side of this graphic, unfortunately, not the same projection. But we see a pretty strong El Nino. It had weakened a bit from this point. It tends to peak in December, but clearly in an El Nino year, we see the warm water in the Central Pacific. But look to the north, very different from this year. We see a lot of cold water in the North Pacific, north of Hawaii. If we look in the Northwest Pacific, we see that extending over here toward Russia and parts of Japan. Very different from this year. And we also see some warm water here embedded in the Gulf of Alaska and kind of extending off the west coast of the United States. If we go ahead and look at the jet stream from January through March of that same year, I think we can see the problem pretty quickly in what happened in this water year. The cold patch here, north in the Pacific, perhaps strength in the Pacific jet, that focused it on the Pacific Northwest. That brought a lot of that rain. Remember, we saw those green colors here in the Pacific Northwest in terms of anomalous precipitation. We don't see a big subtropical jet stream here. If anything, it's shunted well to the south over Mexico and Florida, and that's not going to deliver much rainfall to California here. So we really had kind of a dominant Pacific jet, but no real subtropical jet stream, which is what we're looking for in a typical El Nino year to deliver the precipitation to California, at least southern California, parts of Arizona, parts of that Colorado River Basin, and perhaps the Sierra Nevadas as well. Well, what happened in 2018 and 2019 during that same time period? Here's pulling 2019 February 1st sea surface temperature anomalies. The first thing that comes to my mind looking at this map in comparison to 2015, in fact, I'll just go ahead and show that one and jump back to 2018 and 19 here from February 1st, 2019. Much weaker El Nino. We don't see this kind of big jumping off the page warm temperature anomalies here in the Central Pacific. Sure, they're warmer than average. That's why we were in a weak El Nino, but again, not much to write home about. But look to the north, much more kind of nebulous, not as strong kind of temperature signal here. If anything, maybe a little bit warmer than average here across the northern Pacific as a whole. We did still see that northeast Pacific a little bit warmer than average. Not much of kind of that Hawaii cold patch here. Again, this is, if we were to take this in relation to this year, we're quite a few months out from now. So these sea surface temperatures in the North Pacific can change in that time period. But we didn't see that big kind of cold patch in the North Pacific. And if we look at the jet stream pattern over, again, that January to March timeframe for 2019, when that peak of the water year is really kicking in for parts of California and parts of Arizona, very different jet stream composite from that year over that same time period. Here you see almost a textbook El Nino, a split in the jet stream north of Hawaii that sends this big upper level ridge over the Pacific Northwest. There's that forecast this winter for your textbook. El Nino tends to bring warmer and drier conditions in, just like the long-range forecast right now for the end of October, where we have this upper level ridge bringing warmer and drier temperatures in. We see that same upper level ridge here in the 2018 to 19 jet stream. And here's our subtropical jet stream. Draw a line from Hilo, Hawaii over to San Diego, California. That's to help bring in the rainfall events that we saw in 2018 and 2019 at the peak of the water year, when we expect the most water and the most snowfall water content to get into California. That's when the subtropical jet was aligned with that, and we had a big water year. So what I see here is, I can't say just because we're going to have a strong El Nino, we're going to have a big kind of textbook water year. But what we also saw here is we don't see this year that big cold patch in the North Pacific. And we're not really seeing that in the forecast either. So keeping an eye on these things going forward. Here is up to date. I grabbed this. This is the same graphic you saw earlier, but on the same projection of the 16 and 19 maps, just to give a better comparison here. So very warm El Nino developing here, a little bit east-based, as we call it, when the warmer temperatures are over here by the South American continent. Expecting these to start to nudge out into the Central Pacific. But we do not have that cold patch north of Hawaii. If anything, it's very warm. We have some cool water here, perhaps in the northeast Alaska. This could change certainly over the next few months. And if we take the sea surface temperature anomaly forecast from the ECMWF seasonal model that came out recently, we'll start it here in October. This is what we were just looking at. See that little cold patch there in the northeast Pacific, all that anomalous warmth north of Hawaii, that east-based El Nino. Take it out to November of 2023, out to December of 2023. Then there is where I said that kind of warm water expected to nudge out into the Central Pacific as we peak a very strong El Nino here into January, February, and March. El Nino here in the Central Pacific, warmer water north of Hawaii, perhaps some warm water pushing into parts of the northeast Gulf of Alaska here, and we still see the remnants of that cold patch east of Hawaii. So we don't see a big cold patch here in the forecast north of Hawaii. It's possible the ECMWF model is not going to capture that if it were to develop, but at least right now I see no sense that, we're just going to have a repeat of the 15-16 El Nino just because this one is going to be pretty strong as well. I also don't see, we're going to have a total redux of the 2018-2019 El Nino, which was a lot weaker. It's hard to say right now. I know that's not the perfect answer, from a meteorologist long term. If there are hints going forward right now in some of these seasonal models, One kind of forecast that's come out recently here from the ECMWF seasonal model monthly for December is it's gone a bit colder for the western U.S. There's some kind of correlation there, perhaps with a more east-based El Nino, keeping an eye on that. Perhaps we look at a start of El Nino being a little bit colder in for the western U.S., a little bit drier as well. We kind of saw this shift in the ECMWF seasonal model for precipitation where it wants to start this water year a bit drier. So if we look at the December precipitation anomaly, a little bit drier for parts of California. Don't see a big wet anomaly, perhaps all the way down here, but nothing substantial. If we go out into January, that precipitation anomaly is now shifting significantly drier, not only for the whole state of California, all the way through Southern California, perhaps even parts of Arizona. I think this, was maybe a concern if people were thinking about, a big kind of textbook El Nino water year. But we talked earlier in the video how February to March can kind of make or break a year. And as we shift into February of 2024, okay, now we perhaps see that more textbook El Nino, drier in the Pacific Northwest, wetter in Central and Southern California. March, at least not as bona fide of a dry signal, and perhaps even April, looking at a little bit drier north, wetter in parts of Nevada and the Sierra Nevadas here, all the way through April of 2024. So not a huge signal either way. I'm not seeing right now a total dud of an El Nino in terms of a bountiful water year for California. I will say if we get a more extended Pacific jet stream and we cool down those waters significantly in the Pacific Northwest, perhaps, not necessarily the best news for parts of California, but good news for folks looking to get out of the seasonal drought we're concerned about in the Pacific Northwest. If we do see that kind of textbook split flow and we keep some of that nebulously warm water in the North Pacific, maybe we're looking at a more textbook El Nino water year as we get into February and March of next year, perhaps starting this year a little bit drier and cooler in December. I'll say it's hard to guess, that far out. If I knew exactly what the weather was, exactly where everyone was, I'd be living large somewhere. But nonetheless, we do have these signals here we're keeping an eye on. The Climate Prediction Center kind of spelling out that story as well. If I look at their forecast for November, December, January, we see that warmer Pacific Northwest. That's consistent with El Nino. We don't see a strong precipitation signal either way for November, December, January of kind of, let's call this the start of the water year. And that's kind of consistent with that maybe drier start, but shifting wetter and kind of the peak of the water year. In fact, if we go over and look at February, March, and April, we see the Pacific Northwest staying a little bit warmer than average, but finally getting more of this above average precipitation signal into parts of Arizona, Central or Southern California here. So perhaps they're seeing that same signal as well. Another thing I wanted to look at was the IRI. We were looking at their all the models that they were looking at to forecast El Nino earlier. This is their multi-model probability forecast for precipitation for January, February, March of 2024. This kind of multi-model was very good at signaling some of the drought we saw in summer of 2023, so I like to refer to it here. And they're looking at maybe a more kind of classic Pacific Northwest, a little bit drier, parts of Southern California, Nevada, Arizona looking wetter. And I do want to mention Hawaii. Unfortunately, the correlations here with El Nino are a bit strong, that we're looking at a very high chance of, unfortunately, precipitation deficit here through the water year in 23 and 24 for the state of Hawaii. Not uncommon at all for a big El Nino event in Hawaii. Jumping a little bit closer to present here, the 30-day forecast looking a little bit drier. This is not a surprise, kind of given what we saw all the way from week 1 through week 3, all maybe even down to week 4, getting into early November, seeing a shift toward a kind of a warmer, drier pattern, less progressive, less systems coming through here. We're seeing this here in the ECMWF weekly model out all the way to November 17th here for the 30-day precipitation anomalies here. Perhaps has something to do with the MJO, which was very kind of progressive earlier in parts of September and early October, but has really stalled out here in phase 8 and 1, not really going anywhere anytime soon, it would appear. You don't see kind of a rapid transition back through the maritime continent or back out into the Western Pacific, so perhaps that playing a role in the more stagnant pattern we'll see going forward. I hope that sheds a little bit more light here to kind of sum things up, looking at a potentially cold, drier start to the water year, very much focused on those North Pacific Ocean temperatures to see where that kind of split flow sets up in the jet stream. Does that give us a more kind of typical subtropical jet stream where we get the water year in February and March that we were expecting? That maybe we're leaning that way right now. The Climate Prediction Center kind of tracking that as well. I'd say the bad news there, for California is that could have kind of a bountiful water year when it's all said and done. But if you think about February and March, that's when, we're talking about pollination, we're talking about blossom, more field work, disease pressure. If you kind of had to bring the water in and that snow water content, if you got to pick and choose, maybe December and January would be a better time for that. But we can't pick and choose with the weather very often. If I could, I certainly would. All we can do now is look at the signals and give you the best guess going forward, and that's what we try to do. If you made it this far in the video, I appreciate you watching. Have a good evening. Thank you.